All right, Harold, thanks for volunteering for today. Do you mind saying hi, and then you can share your screen and jump into today's discussion.
Okay, thank you, Ted. So my name's Harold Anderson. I am kind of a newbie with data science. I went back to school and got my master's in data science during the pandemic, and so that really kind of lit my my fire with data science. I'm really getting into it, and all the different languages, Python, SQL. And then I found this group, and this is the second book club that I am leading a chapter on. Let me share my screen. I don't know, have people had a chance to check on chapters? I think it's 14 and 15. Anyone?
Yes.
I don't know if you've seen some of the errors, but there are a couple errors that I've noticed on the website and on the book. And I just, you just kind of have to go through them and keep going and not really pay attention to some of the errors. But let me share my screen here. Can everyone see?
Yes.
There we go. Yep.
Okay, great. So chapters 14 and 15. SQL in 10 minutes is the name of the book, the abridged name. And so I had chapters 14 and 15, like I said. Here's kind of just a general description of what we're going to be going over today. Chapter 14 is about combining queries using unions this time, not joins. And then same as using multiple where statements. I don't know if you've got a preference. I've tried both. Thank you, Ted. Not really sure what that was. I apologize. And then chapter 15 is about inserting data using insert statements, 3 different types, and then the differing syntax, kind of just a best practices way of using that inserting data. So unions, 2 scenarios in which you'd use combined queries to return similarly structured data from different tables in a single query. And then also, well, before I get to the second scenario, here's what that looks like. You got your select statement, you listing the table name, and then you're using where to filter, and then there's that union statement there combining. And according to the book, there's no standard SQL limit to the number of select statements that can be combined, but consult with your DBS documentation. And then here's the second scenario, which I kind of had trouble thinking of an instance where you would be doing this. I thought maybe self joins. I don't know if anyone else has a better instance, but you're performing multiple queries against a single table, returning the data as one query. And a union must be composed of 2 or more select statements. That's kind of obvious. And each query in a union must contain the same columns, expressions, or aggregate functions. And column data types must be compatible. They need not be the same name. If the column names are different, the first name is used, even if it's an alias. So those 3, those are kind of just the rules. Whoops. Those are kind of the rules for using the union. And so moving on, unions automatically removes any duplicate rows. And so if you want to keep duplicates, the union all use that that wording, that statement to keep the duplicates. And then sorting union queries, you only use one order by statement after the last select statement, also kind of obvious. And then this is for, I guess, other ways of using union. You can use except, which is sometimes called minus, and it's similar to a left join, I think. And then intersect is similar to an inner join. I think that's, I don't know, correct me if I'm wrong, Ted, but that was kind of what I got from that. And then, so that's chapter 14. And let me check the chat. Yeah, does anyone have any questions?
All right, one sec, Harold. I'll add a couple comments. I'm just trying to manage. I booted the person who was interrupting, but I think I accidentally booted somebody else too, and I'm trying to get them back in. So just 1 second here.
Okay. And I can keep going unless you have something you want to talk about.
There's nothing deep. Hold on, just 1 sec though.
Yeah, no problem.
I have a question. I thought that minus is like set minus. So we remove everything. We just do not add any null values like with the left join. We actually remove rows.
With the left join?
With a minus.
With the minus.
We remove from the first table, we remove everything which agrees with the second table. This is what I thought.
Yeah, I'll have to check on that again. I had trouble with the minus, really figuring that one out.
Yeah, so I haven't used minus with unions or in any other version. There's versions of SQL that allow you to do sort of like a set difference, right? So if you have a query and it's going to return 100 rows, and then you have some other whatever bunch of stuff and it's 20 rows, then you can say, hey, I just want the 80 rows. I want the 100 less those 20 that overlap. I've used a lot of Microsoft SQL Server. I don't know if they currently support that. I know they didn't used to, so haven't really used that. The main place where unions come in just sort of their simple form, okay, is sometimes you just want to combine things that maybe are they may be coming from two different places, hypothetically. I don't know if I can come up with a realistic real world example, but so let's say you have one table that has the lists of patients who are assigned to doctors, okay? And for some reason, because of the way the system works, you have a completely different list of patients who have had appointments. And so if you wanted to do something where you say, I want a list of all the patients that are either assigned to Dr. Smith or who Dr. Smith saw, because, sometimes doctors just see people that aren't their regular patients, that, for whatever reason, right? There may be some other way you could do that, but the really simple way you could do that is you do a query on the first table to say, here are all the patients that Dr. Smith is assigned to him. And here are all the patients that Dr. Smith saw in this other table, the doctor saw in the last 2 weeks. And then if you just line up the same thing, so I have first name, last name, whatever, the exact same columns, then you can union those two things together. Okay, and it'll just combine the rows from both of those queries. there are some use cases where I actually do it on things from the same table because it makes my life easier. But the really, really helpful case is when it's just two completely different tables, then there's not really a way to join them per se, you know, 'cause they don't.
Yeah, and the reason I thought of the join example was just reading in the book. It says, you know, it says sometimes called minus can be used to retrieve only the rows that exist in the first table, but not in the second.
Yes.
It kind of made me think the way
Yes.
that
You normally do an outer join when you want something like that. Okay. But you can, I don't know, because I haven't really used, you know, that version of it, but and again, I could create a very artificial way of combining the rows from two different select queries by joining them together, but that's really not what you're trying to do in my example of saying, you know, patients that meet this or patients that meet that, right? So if you're doing this on one giant table, then in theory, you can write a query that has a certain where clause. You can write another query that has a certain where clause. And then you can just write a new query where you say where the first thing, all of that in parentheses, or the second thing, all of that in parentheses. And that, you know, that's the way you can combine two queries against the same table. But if they're on different tables, there isn't really a convenient way to do it, except union is the thing that you do. So if not necessarily for performance, but if I'm just trying to write clean code, that example I just gave you where you have these two queries and they both have long where clauses. You could do that where you put it in parentheses and then you have an or and then you write. It might in the end actually be more readable if you just left them as two separate queries. Select this, select that, and you stick union in between them. And then, you know, especially if you know there's small queries, so there's no real issue of performance, right? If these are 100 million row tables, you probably want to do a little experimenting to see if there's any difference. But if you know that these are small tables with a few hundred rows, it doesn't really matter how you write it. Even if it's inefficient and it takes double the time, it's going to be 2 milliseconds instead of 1 millisecond. So it doesn't really matter. That might in the end be a more readable format for it. The one comment I wanted to make is that in my regular use of SQL, I do use union, and I just want to emphasize the difference between union and union all. Okay, so union is sort of what came first. It's sort of like the idea of the set operations, and so when you do set operations, you can't have a row twice. Okay, and so it will SQL serve that your SQL database will explicitly look to see if you union two things together, whether or not they share any data in common, and it'll deduplicate it. So that is both a performance hit and sometimes not what you want. So if you truly want like the behavior of this second query is just getting concatenated with the first query, then union all basically says, don't even bother checking if the first one's 20 rows, the second one's 30 rows, guaranteed give me 50 rows, even if they're identical. Just give me the 50 rows. I know what I'm doing, just concat the two of them, combine them, and just do that. So, so I've definitely had situations where I have something where it's like, oh, I'm looking for patients who we saw last year and this year, and I write a query and it's already a screen full, right? And now I want to do another query of patients who I saw 2 years ago, but not last year, right? And so then that's another screen full. To figure out how to merge those two into one, it's just a lot more readable just to leave the first query alone and then say union the second query, union the third query. And you can union multiple things. I don't remember if the book shows more than 2, but you can union 3 or 4 things together. And it's not common, but you probably should just know that it's possible.
So that's the SQL equivalent of Python's concatenate, or as close as it gets.
Yeah, I think Python concatenate can do extra more powerful things, but like the vanilla version of concatenate is just stick this on the end, add more
Union
stuff.
all.
Yeah, and then union all is the equivalent of that.
Concatenate can do, sorry, concatenate can do merging, I mean joins as well. So it can do more.
Yeah, that's
But-
why I'm saying it's not the exact, it's the equivalent of the super simple case of concatenate.
Yes, it is more like if you take NumPy and you want vertical stacking of matrix, then it is what it does. But again, it is that union all, that no checking for duplication.
Yeah, and I think if you're an R user, like rbind is just basically adding rows to the bottom.
Yes.
Can we see the slide regarding the addition and subtraction clauses?
One of my slides.
Yeah.
Yeah, can you go back to that one, please, Harold?
Let's see if I can find this one.
This,
It might be the one that had the except and minus.
yes, that's the slide I'm thinking of. There we go. Except and intersect, similar to interjoin. Do we have examples of this selection criteria? Is the keyword minus in this situation? Or is it except?
In the book, minus, it says sometimes called minus. It says except, and then in parentheses, sometimes called minus. So I mean, I can even try and just run a quick example.
All right, if you can, but I don't know that it's going to be that easy to come up with. Basically, if you think of regular union being a plus, so I've got 30 rows, and then if you do a union with another 20 rows, you're going to get 50 rows, perhaps less duplicates. Or if you do a union all, you're going to guarantee to get 50 rows.
Okay,
if you do a minus, then basically, right, if you start with 30 and you minus 20 rows, and let's say all 20 of those are a subset of the 30, then you'll wind up with 10 rows.
Yeah.
Okay. I've never used it. I don't think Microsoft SQL Server supports that. It's actually something that's goes way back in the database theory, this idea of minus, but I guess for whatever reason, it was harder to implement. And so a lot of vendors did not implement intersect minus type stuff.
So the keyword except and intercept are used in place of the keyword union?
To be honest, I'm looking at the book and I'm not even sure, and I've never used it. So I don't know if anybody has, if Oracle or some other system supports it and you've used it.
I can just do a quick, let me just check. SQL
I
minus.
do. While you're checking that, I do have in my notes that I think it's supported in Oracle.
Okay. Yeah, I've got posts. What is mine? Post GRE, and it didn't take either.
Oh, Postgres, yeah. Like I said, a lot of people haven't supported. I haven't really thought about it. I think it's harder to implement. So people.
Yeah, yeah.
But the comment that you made earlier. So if I had a query that returned 30 rows and I had a query that returned 20 rows, instead of using something like a minus, I could do a left join, right? Start with the query for the 30, left join it to the 20. And if I say, I'm only interested in the rows where the, let's say we're just joining on one column, an ID column, where the ID is null, then that will eliminate all the matches. And so that will take away the 20 rows that actually match and leave me with just the 20 tables, the 20 rows that don't match. So even if you don't have that extra functionality, that is a way that you can do this. And that is sort of, I mean, it's one thing that I, ask people if they're familiar with, because it's not the most basic thing. Usually you're looking for the things that are in common between two tables, between two queries. But every now and then that it really is what you want. You want the things that are not in common.
Yeah, so it sounds like minus and intersect and accept are kind of little specific to whichever language you're using or program. I haven't checked. Is there any questions in the chat? Can someone check on that?
We're good.
Okay. Okay, so next one, chapter 15. Use of the insert function often requires special security privileges. Obviously, you're making permanent changes to your data, and so the insert command is going to have or should have some kind of special security. And so it's used to add rows to a data set table. Can be used in several different ways. The book lists 3 of them: inserting a single complete row, inserting a single partial row, and inserting the results of a query. And there's how there's the syntax for inserting a single complete row. Insert and into are the keywords, and then you got the table name. And then one thing I didn't put here that the chapter mentions is after the insert into and the table, putting in parentheses the all of the column names. And just because it switches them around, it says, that's best practice. Oh, and then it said some SQL does not require the into statement, but again, best practices, you probably want to keep that insert into. And then a single partial row, it's just like the complete row, but you're just omitting whichever column names you want to omit. And then the last part of the chapter 15 is the results of a query. Before we get to that, it does mention inserting retrieved data into an existing table. This is the result of a query. So here's how it should look. Insert into, and then you've got the table name, and then you've got the column names, and then you do the query, select, and then whatever you want to select in your query and put into the table, and then you put from is the existing table that you're adding to, and then here is the last example with inserting data. And then they just say, yeah, here's some differing SQLs. They use select asterisk select into instead of create select. So just something to keep in mind. And then some rules with inserting retrieved data into a new table. Joins can be used. Data can only be inserted into a single table, obviously, and then any select options and clauses like where and group by can be used with the inserting data from a query. And that's pretty much it. Oh, they do mention that this is a great way to work on a table without worrying too much about altering it, is to do this as just copying one of the tables using this syntax and working on that copied table. So that's chapter 15.
All right, great. Thanks, Harold. So I think the first chapter, combining two queries, combining the output of two queries using a union, it's something that you should know, and it's not super common, but sometimes it's more convenient. If you don't remember how to do a union, there's probably some kind of workaround. Okay. Inserting will come up. I think when we get to the end of the book, I'm going to add a topic on sort of more advanced queries using either temporary tables or things like that. And so if you're gonna create a temporary table, you need to insert the rows into it. You need to know how to do that. But like, as far as like inserting into the production database, if you're doing machine learning data science, you're not likely to need to know how to do that. I don't think you're gonna get an interview question about inserting per se. Okay, but nevertheless, okay, you can insert one row as Harold showed. If columns allow nulls, you don't have to specifically provide those values. So that was the second thing that you covered. Okay, so if they allow nulls, then you can omit those, and then the database will just simply put a null for any of the columns that you don't specify. If you have a column that requires that you fill it in, doesn't allow nulls, and you don't specify it as part of your insert, then you will get an error message. So I agree with the author. Again, this is, I don't think, as important for machine learning, but if you are going to write an insert, best practice is you list all the columns that you're inserting into. Okay, if the table ever changes or whatever, you're going to get an error message. But in this case, you want an error message. If you thought it was first name and then last name and then address, and then they got rid of the address field and they changed it to email address, you don't want to be putting somebody's mailing address into the email address field. You want to get an error message, you know? So I do think that that's a best practice. And then it's somewhat required if you're going to omit columns, then you want to sort of specify, here are the only columns I'm giving you, and then the values that correspond with it. So again, I don't think it's super important, but you know, probably good for you guys to at least see. And so then the other two things, I think, again, you probably will wind up using them as we get into the more advanced stuff, where you're going to create a temporary place where you're saving the results of a query, and then you're going to do further things with it. And so the more formal way is you have a table that already exists. It might have 0 rows, but the table exists. Okay, and then you use sort of the same syntax. Instead of saying, if you want to bring your slide back up, Harold, instead of saying insert into this table and here's the values I want you to insert, you know, John, comma, Smith, comma, birth date, January 1, 2001, right? Instead of explicitly listing those values, you say insert into this table, and then you can have any kind of select statement you want. Now, obviously, the columns in that select statement have to match. You have to have the same number of columns and the right data types and all that, but you can have any kind of query. So that is the sort of the formal way, and there's sort of not a reason why you ever can't use that syntax. I'll be perfectly honest. If you go to the next slide, I do use that syntax fairly often. So the Microsoft SQL version is select into as opposed to create select. And the super convenient thing about that is you don't have to name the columns. All right. So if I write a select that returns first name, last name, maybe it's maybe it's the slide after. So yeah. So if I write a select query here that returns first name, last name, birth date, and address, those 4 columns, then if I say the Microsoft SQL version of it, select blah, 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 those 4 column names into my new table from blah, 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 it will create the table that I name, and it'll create the columns named exactly the same as whatever they were coming from my select query. So when I'm not doing production code, especially if I'm just doing exploratory stuff, it's super convenient not to like sit there and have to like type out, especially if some of the column names are long, they have underscores and capitals and whatever kind of stuff. Just, I'm a lazy typer. So I do actually really like this shortcut. I would say I tend not to use it so much in production code. You know, you can go through sort of the formal step of you create the table, and so it has all the right columns and everything's defined. It has no rows in it because you just created it, and then you just say insert into table, and then you can have a select. And the select can return 1 row, the select can return 1,000,000 rows, and actually technically the select can return 0 rows and you will not get an error message. It just means that nothing will get inserted. That's perfectly valid to have an insert that inserts 0 rows.
And so would it just look like that? I mean, if you're, well.
Yeah, so the syntax on your slide right now, it'll create a table called, I think you're missing a space, but it'll create it. Oh yeah, it'll create a table called customer select, and it'll have 3 columns, and the columns will be named X, Y, and Z. And you don't have to ever specify that because that's sort of indirectly specified based on when you run the query, that's what you're going to get.
And when you said you use it frequently, is it mostly just you take all of the columns?
No. When they say star there, they just mean that like you can do whatever you want.
Okay.
They don't mean that you have to use star. So mine actually looks like select X, Y, Z.
Okay.
It's just that instead of create table as select, you say select column names into new table name. So it's just a slightly different syntax. Instead of create table at the beginning, it goes between the select list and the from. It's actually in some ways kind of an inconvenient place to put it, but that's just the way Microsoft SQL Server looks.
Okay. And then you can go down here and just do whatever, like.
Yes.
Okay.
I'm confused by your into statement in this create table statement. Is that the position that it's supposed to be in?
Yeah, so let me just type it. Unfortunately, you can't see anything I'm typing.
Do you want me
until
to stop
I hit. So the into comes between the select list and the from. So what I wrote in the chat is select A, B, C into new table name from, and then everything else that's in a standard select. And you can have anything that you are allowed to use in a select. In fact, you can use unions, which we just looked at in the last chapter. Weird looking if you use unions, but it's legal. But basically what this says is create a table called new table, and whatever the column names are that's coming back from your select, just use those. So if you use something like calculated columns, so let's see, can I copy and paste this? I can't remember. Let's me. So if instead of C, I had C plus D because they're both numeric columns. Okay. If I literally have that syntax, I'm going to get an error message because the calculated column C plus D doesn't have a name. So I would have to literally do C plus D as some new column name, and then it would be perfectly happy because every column in a table has to have a name, and it's not going to make up a name for me. It needs the query to actually explicitly return column names. So the philosophy of the relational databases is, again, this goes way back to like, I think at least the 60s, where memory and disk space were very expensive. So we're only going to store one copy of everything where possible. And in doing that, you pre-specify the schema of all of your tables. You pre-specify how many rows, how many columns, what the data types are. And in that world, basically SQL Server, your database engine, will know a lot of things about your query. And so, for example, in this query that I just typed in the chat, it knows that A is, let's say, the name, and so it's a string of up to 50 characters. It knows that B is the birth date and that it's of type date, you know, and it knows that C and D are integers and it can add them together and that the result will still be an integer. So it's able to figure a lot of these things out in advance before it even goes and looks at a single row in any of those tables. It actually is doing all of this. So relational databases tends to be very heavy in terms of like this schema business. It knows what your types are. If you're used to like programming in Python, I can set the variable x to equal 10, and then I can change x to equal 2, and then I can change x to equal 3.14. No problem. SQL, you don't get to do things like that. If something is a string, then it's forever string. You don't get to put, you know, floating point numbers in there and things like that. So, but because it has that strong schema, it can do that thing where, like I said, this is not necessarily, I have used it in production code. It's not necessarily the best idea. It's actually in a later chapter that we actually formally go over how do you create a table. But I would say probably the best practice would be to do a create table statement and then just say insert into my new table and then select blah, 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 whatever that is. Any other questions?
Sorry. So Ted, would you say that because at the outset, when the tables are created and we have the different data types, because it knows this from the very beginning, is that what allows SQL to be so fast?
I'm not sure if that specifically is what has them be fast. There are certain things that it has to, any system, any programming language, anything, you know, has to be able to know certain things. So if you say, does A equal B, right? It has to know what type A is and what type B is. And so in some way, you know, it has to do that. But what I will say is that how modern database systems work is they figure out a plan for how they're going to run your query, and they try to optimize that plan. And absolutely, knowing the data types is part of that. Okay. And it is more efficient if you can just know what something is and then run really, really, really fast. So if you can imagine, the nightmare scenario would be you have a column and it's like Python. Each row can have anything in it, right? Like a list. in a list, in a Python list, you could have a string, and then the next thing can be a number, and then the next thing. So in Python, every time you touch something, you go through all this code that says, what is this thing anyway? Is it a string? Is it an integer? Is it a floating point number? And so you're running that what type is this anyway code over and over and over and over again. And so if you were ever doing a SQL operation on 1 million rows and you had to do that every row, that would be slow. So when I say join the customer table to the order table where customers.customer ID equals orders.customer ID, right? The database knows that those are both integers and it doesn't have to check every row to see what they are. So then, yes, to that extent, that's one thing that makes it particularly fast. But the other aspect, which we haven't really talked about, is that generally speaking, the machine that's running your database is a much bigger, much faster machine than your laptop. Okay, so if you had that machine running stuff locally, a lot of things would run faster too anyway, but they're using that shared model where different people are running different queries against the server. And so you're sort of spreading the cost of that very expensive big server, right? And so there are things you can do if you have a big honking machine with a lot of memory, and you can sort of optimize the way you store the tables, and then some other things that we kind of get to at the very end in terms of things like indexes to speed things up. So if you have a big enough company, a big enough database, you will have somebody whose job is to be the database administrator, and they may be managing some of these things to keep the performance good. Okay, generally speaking, if you are the data scientist, the machine learning engineer, I'm not thinking anybody's going to expect you to know about these things. They expect you to know how to write a select statement to get the data that you want, and it's probably somebody else's job to figure out exactly how to create the tables and how to make them run fast. So I could definitely get into it more, but I think I'm just going to save a separate dedicated time to talk about
Sounds good.
some of the stuff that we've purposefully skipped. Because again, if some people are interested, great, but I think a lot of you can get away with never knowing how is the information in a table with 1,000 rows stored anyway.
Just a question. Do they use hashed indexing?
No, no database that I know of uses hashes. What they actually use are a version of binary trees. And so if you're familiar, binary search is a pretty fast operation. But instead of binary, which means that it always branches 2 ways, relational databases will branch multi-ways at once. So instead of calling it a binary tree, it's called a B tree.
It's still not quick as hashed information.
SQL has to support ranged searches, not just individual lookups. So hashing is not necessarily fast for ranged lookups.
Oh, okay.
Right. So if you, so anyway, so that's why they use that. And if you're familiar that binary trees, it's the log base 2, to get down to a leaf of something. Imagine that you
Yes.
have a table where the base, instead of 2, the base is, let's say, 50. The log base 50 of a number is really, really, really small. It's like you need some really ginormous number to have the log be even 3. So the depth of these trees, the height, depth, whatever you want to call it, tends to be like 3 or less, or maybe if you have a really huge table, like 4 or less. So it's extremely fast in order to get down to the leaf. But there are still some tricky things in SQL Server to optimize when you're returning multiple rows. If you want 1 row, then it's like super duper fast, and it would be even faster, as Maya said, if you used a hash table, potentially.
Okay.
Cool. Any other questions? Did you guys have any questions from the exercises in the book? So let me go back 1 second. So at the bottom, I figure most of you probably don't keep reading and reading, but at the very end, at the bottom of all of the meetups, we do have the link here for our Slack, and I am starting to post problems, practice problems there, and people haven't, but we can have discussion if people have questions about some of the problems. So we've got a couple minutes if people can stay till the full bottom of the hour. So this one looks relatively straightforward, okay? So we've got two tables, employee and department, and it looks like the department ID here is what connects between these two tables, so you can join on these. The question is, write a SQL query to find employees who have the highest salary in each of the departments. Okay, so if I asked you, what is the highest salary for each department? All right. You guys want to just sort of think about what that query might look like. So again, here's a list of all the departments. Let's say this has 10 rows. And here's a list of all the employees. Let's say this has 200 rows. And each employee is only in one department. And each employee has one salary number here. So how would I list the highest salary for each department?
Group by and maximum.
So
But we need a person. Okay. Salary, yes.
So I'm going to join the two tables, right? Yeah, sorry, go ahead.
Will there be 10 results?
Yes, because there's 10 departments and I want to know the highest salary for each department. I'm going to need to, my correct query should return 10 rows.
In return 10, got it.
So I can select something, don't know what. Well, let me just say, and then I'm going to have from, right? Department. And I'm going to join it with, what is this other thing called? Employee. And I'm actually going to say, because this is the way I write queries, so that I can then say on d.id equals e.department. All right. So there's my join, right? I have to connect these two tables. So, well, I think Maya was the one that said we're going to need to group. So somewhere there's going to be a group by. Right? So this will give us one row per department.
So we're just returning the name of the department and the salary, right? The max salary.
Yes.
Okay.
Yes. So I could actually change this to say group by ID and name. Okay. So then I could return each of those. And then what's the thing that we want to return?
Maximum salary.
So max dot salary. So I think this query will correctly return a list of all of the departments and what is the highest salary in each department. And then if oftentimes when you do something like this, you really want an order by. I don't know what might be wanted, but maybe it's alphabetical by department name. Okay, so I'm just going to throw that in. This doesn't necessarily, I don't know if it was specified, in the problem description. All right, does this make sense for you guys in terms of this shows you a time when you need to join two tables because I need 10 rows, one for each department, but the salary info is not in the department table. The salary info is in the employee table, so I'm going to have to join those two tables together. Okay. If the employee table has 200 rows, as I was saying, as I just made up that number, when you do this join, inner join department with employees, assuming that every employee has a valid department ID, it's one of these 10, then this join will give you 200 rows. Okay, it's going to be the same as the number of employees because each employee has a perfectly valid department ID. If for some reason people didn't, then you might actually get fewer than 200 rows. But if every one of these department IDs is a valid department over here, then you will wind up with the full 200 employee rows when you do this join. Sorry, Harold, you were going to ask.
Yeah, sorry. I was just wondering, you know, if you knew, like, let's say for whatever reason you knew there were only 3 department IDs and you knew what names they, you know, what types of department they were, you could just do it in just that one table, right? Couldn't you just use the employee table and then group by department ID?
Oh, actually, yes. So if I just wanted to find the highest salary by department ID, I could just, you're right, I could get away with just using the employee table. But as soon as I want to return the department name, then I have to do a join.
Okay.
So yes, that's good. And that would be smaller, easier to read, faster query if we didn't do the join. So I like that. That's a great suggestion. So it just depends on, you know, what the question is.
Okay.
So
yeah, like you were more interested in just what the highest salary was, regardless of what department. That would be one way.
yeah, and then people would have to know what the IDs are. So if people are very familiar with the IDs, great. But if the IDs are just complete gibberish to people, then you better actually. And in some cases, people wouldn't even want the ID. They'd say, no, just give me the department name. I don't even want that weird ID. That's just some weird database thing. Like, we in the real world don't even use that thing. Someone in the database world created that, but I don't know what that means. That 17, I've never heard of it, right? So in that case, then you wouldn't even return that. You would just return the name. And then if that's the case, you really have to do the join.
Yeah.
All right, so there are 2 ways in which I can make this query that I wrote on the right. I'm not 100% sure. I haven't actually tried to submit an answer to this question on LeetCode. But there are 2 ways I can just share with you right now that I can suddenly make this problem quite a bit hard. Okay, so one way I could do that is I could say, instead of the highest salary, tell me what the second highest salary is in each department. And even if you assume there's at least 2 unique salaries, okay, so we don't have to worry about the edge case where there's only 1 or whatever. Trust me, your query is going to get quite a bit longer. It's going to be more complex. Okay. The other way in which this query can suddenly get much harder is if instead of me saying, tell me the salary that is the highest in each department, tell me the name of the person who has the highest salary. Okay, so in machine learning, whether or not our language supports it directly or not, we have this concept of max. Okay, so if there's 20 people in the department and one person makes $1 and one person makes 2, one person makes 3, 3 is the max. Okay, you will sometimes see argmax. Okay, especially if you read ML papers. So your language might not support it, but argmax says, you know, the person who has the max. So who is the person who had 3? 3 was the max. Who's the person who had 3? That's what we're asking for here. We're asking for the argmax of the salary. SQL Server, I don't know any implementations that support argmax. Okay. And so I have seen sample queries where they ask you not for what was the max salary, but what was the name of the person with the max salary. So if you want, you guys can noodle on it, but I will say that both the things that I just presented, the second highest salary and the person with the highest salary, those are quite complicated. I do think that you could get asked a question like that in an interview because they may have 15, 30 minutes allocated for this. And so, you know, they're going to want you to work through it. But I just want to say that some of the techniques for solving it, we haven't necessarily talked about yet in this book club series. So it can be done using just joins and left joins and things like that, but it's gnarly. So, I wanted to mention it for two reasons. One, just to get you guys thinking about more complex SQL problems, but also as a little bit of a warning because I've seen problems labeled as here's a join practice problem, and it's really actually incorrectly labeled. It's not an intermediate problem. It's actually more of a hard problem. It requires more knowing more SQL than just joins. It uses joins, but almost everything uses joins. So I just wanted to kind of caution. So even like the stuff that I posted on the 4 problems that I posted last week, they had unnecessary complications where they threw in things like, oh, and if the person's name happens to, you know, this isn't exactly what they said, but they're like, if the person's name happens to be Smith, then skip them or stuff like that. They just made it unnecessarily extra complicated, and you guys don't necessarily know all the SQL that you would need in order to do just weird special cases like that. But you should at least understand this main case at this point. I think this is the kind of query that you should be able to write on your own. So then this, I think, would be sorry, I keep pausing and tricking you. This would be, I would say, a beginner to intermediate level query problem. Sorry, please go ahead.
What were the 2 scenarios you proposed? The query that selects the second highest salary, and what was the second one?
Yes, so the second highest salary would be tricky, and then the other thing that would be tricky is the name of the person, not the name of the department, because that we already have. The name of the person with the highest salary.
Are those 2 separate queries you're thinking of? Or
yes, I'm saying either one of those is quite a bit harder than the sample query we have here. Either one of those.
The second one though wouldn't be all that much different than what we have on the screen now, would it? I mean, all we'd have to do is add the e.name column to the select up above, right?
It turns out that it will be harder because this max right now is doing all the work of picking the right row. And you can't really say, comma, what did I just do? Comma, e.name for the row that is the max.
Even if it's part of the group by?
Yeah, in fact, if I literally ran this query, I would get an error message saying that when you group by these things, then these things are allowed to appear in the select list, and aggregate functions are allowed to appear in the select list, but e.name is not part of an aggregate function. And so I would actually get a sort of a syntax error message. And so you could theoretically write this, and you'll stop getting an error message. And then regardless of who has the largest salary, you're going to get the person whose name is alphabetically last. So So if
Yeah, you
there's
don't
somebody
want
whose
that.
last name begins with a Z, you're always going to get Z regardless of what Z makes, because this max and that max are not connected.
You know, I saw such problems somewhere, and they didn't say that there will be. I actually tried a query which I thought is suitable. They said that you will get you don't get a message about an error. You will get any arbitrary name. It is not necessarily a name of a person with maximal salary, because that maximum is
Right. So
it
what
is
you,
not like you choose a row with a maximal value. You just
yes.
choose the maximal value itself.
Yeah. And this is one of the areas where, if you guys were with us at the very first session, I said sometimes SQL, because it works on just sets of rows, it's a little bit frustrating because you're like, no, SQL, I know you know which row is the max because you calculated it. I want you to grab the name from that row, and there's no way to tell it to do that because it's just dealing with these sets, okay? So hypothetically, if we had a function that worked like this, where you said, find the max salary and pull the name from that row that has the max salary, okay? That's what we want. But this function, as far as I know, doesn't exist in any SQL implementations. So,
It is in Python.
yeah, and you also see people just, if they're writing mathematical expressions in a machine learning paper, they'll often talk about the argmax, right? So
Yes, and
so if
here
you're doing natural language processing, okay, and you've got a vocabulary of 30,000 words, and your model has output 30,000 probabilities, okay, it's going to say take the argmax. So whichever word has the highest probability, output that word. But in SQL, there is no such thing as argmax. It'll tell you what the highest probability is, but it won't tell you which word that's from. And if you're thinking like, well, then just tell me, like, was it row 7? Because then I'll just find the name from row 7. These are sets, and sets in SQL don't actually have like row numbers and things like that. And so later we'll see that newer versions of SQL actually allow you to create a row number, and then you can start doing things with row numbers and stuff like that. But in vanilla SQL, there's times when you're like, oh my God, you are just driving me nuts. You're so dumb. Like this is the perfect example. Okay, I know you know which row has the maximum number because you found it, and yet you won't work with me here.
I think it is because SQL tables are changing. So people who created SQL decided that it doesn't make sense to ask for a row number. R has which max, by the way, very convenient.
Yes, this is and this does come up. I mean, you can imagine like your boss is like, I don't want you to tell me the salary that's the max. I want you to tell me who it is. So I do think that is a real kind of interview problem that you might see. And I'm just letting you know there's I can think of at least a handful of different ways that you could find the person who has the highest salary. Some of those we haven't really talked about yet. So I just wanted, but I wanted to let you know, just to warn you that if you're trying to do practice problems, you might pick problems that it says are beginner or intermediate, but you have to be a little bit careful, especially on the intermediate, that they might ask you something like that, like who's the person with the highest salary. And I would consider that to be an intermediate to advanced. It's maybe not a hardcore expert problem, but it is a little bit more, and we haven't finished the book yet. Okay, we haven't quite covered everything yet. So I think it'd be good for you guys to be practicing, but just beware, there may be some problems that you just need to skip if it turns out that they're covering things. Or if you look and see what other people say their solutions are, and if you don't understand them, they might be using some things we haven't covered.
I know
So
that on
let's-
HackerRank,
Go ahead.
Sorry. On HackerRank, people who supply problems, they're actually volunteers, and it is up to them to mark difficulty of a problem, what is the level.
Yeah.
And yes, they do not always, do a good job at it.
The first 4 that I posted were from HackerRank, and I grabbed this one from LeetCode because I actually started to get disappointed because they were unnecessarily complicated. Like I said, this is not the exact thing, but they even had something where it's just like, oh, and by the way, if there are duplicates, or if the person's name is Smith or whatever, like do something different. And it's just like, all right, I know SQL like forwards and backwards, and like my query is now like a page long. This is not really useful for learning. This is just annoying at this point that it has so many different complications. So so I pulled this one from LeetCode, and actually, Sule, I'm glad you reminded me. I'm going to look on Status Scratch to see if they again have some better intermediate problems. Okay, where it's
just quick question before we get away from this problem. So if you know that there are only 3 departments and the department IDs are 1, 2, and 3, you could just do select name and salary from employee where, and then department ID equals whatever, run that, you get that one, right? And then you just do different wheres for each department ID.
So I would say that it's still not quite trivial to find the name of the person that has the highest salary in department 3. It's a little bit easier, but it's still not quite super. It's not going to be as short as this. Not quite.
You can do a subquery.
Yeah.
You can find the person. We can find salary for each department, highest salary. Do a subquery to find this person, and then get a union.
Yeah. So
Of these 3 subqueries. I mean, if there are just 3.
Is this a problem you want us to work on for next week, and then you'll show us the answer next week, or what's your form?
So yeah, I will go over the answer to the person who has the highest salary next week, if you guys want to work on it. Now I know, people have life, and some people will have time to work on it, some of you might not, but yes, I'll go over that answer next week.
And
there is at least one way you can do it using only the things that you have learned so far.
Could you post this in the Slack? The problem?
Yes, I'm going to post it here first, but then I'll also put it in the Slack.
Okay.
So let's see here. I see a question in the chat about LeetCode. And I'm afraid that I don't know the answer to that question. I've been doing a lot of these things for a while, and so mostly I don't practice things like Python, SQL, whatever. And so unfortunately, for me, I just don't have as much firsthand experience. If other people have opinions about where is a good place to practice, I would love for you to share those opinions on our Slack, and maybe we could get some people voting and commenting on what they think, like maybe, for all I know, like maybe Python is really good one place, but SQL, it's, better someplace else or whatever. And that would be a great way to help other people out. But I'll just simply say that right now, trying to find problems, I wasn't that pleased with HackerRank. I didn't find that the problems were explained super well, and I didn't find that they were ranked in difficulty very accurately. So I had previously found this issue in a different, I don't remember what I was looking at, combinatorics or something like that. And now I found the same problem with SQL. So I feel like it's yeah, where HackerRank is taking advantage of people uploading problems, but they don't really have the manpower to vet them to see if the problems are well written and if they are accurately, they have accurate difficulties. So at this point, I'm exploring LeetCode and I'm going to look at Strata Scratch, because I know Sule, you had mentioned it one time before, and at least could be luck, but the problem or two that I looked there actually looked pretty good. All right. Well, thanks for going over with me. Actually, let me stop the official recording right here.